In this video, we are going to discuss the concept of self-referential classes. So, what is a self-referential class? A class which refers to itself is known as a self-referential class. It means a class points to itself, or we can say that class contains a pointer to itself. Okay, and these self-referential classes are very helpful in creating a lot of data structures such as linked lists, binary search trees, etc. Okay, so we will understand this concept by creating a linked list. Okay, so first of all, let us see what is a linked list. A linked list contains a chain of elements. Okay, so these are the elements of the linked list, and these elements are called nodes. These are the nodes of the linked list. So this is node 1, node 2, node 3 and node 4. So each node has two parts. One is called the data part and second is called the pointer. The data part contains the data which node intends to hold. Suppose the data can be a value. Okay, suppose this node contains the value 10, this node contains the value 20, this node contains the value 30, this node contains the value 40. Okay, and the second part is called the pointer part. Pointer part contains the pointer to the next node in the linked lists. So it will contain the address of this node. This pointer will contain the address of next node. This pointer will contain the next node, and the last node will contain a null pointer because it is not pointing to any other node. Okay, so suppose the address of the base address of this node is 1000, the base address of this node is 2000, the base address of this node is 3000, the base address of this node is 4000. Okay, so this pointer variable will hold the address 2000 because it is the base address of the next node. This will contain the address 3000, this will contain the address 4000, and this, because it is not pointing to any other node, it is containing a null pointer, means no address. Okay, so this is the basic structure of a linked list. Because all the nodes are linked to each other, that is why it is called a linked list. Okay, and now let us see how to create this linked list. Okay, so first of all, we need to create this structure of a node. Okay, so as I am saying structure, let us create a struct data type. Struct node, and this structure contains two things. First is the data. Let us write int data. This is the data part, and the second part is the pointer. And this pointer, what this pointer is doing? This pointer is pointing to another structure. Okay, so this pointer is pointing to this node, this pointer is pointing to this node, this pointer is pointing to this node. So it is pointing to something. So we will write star ptr. It means ptr is the name of the variable and star means it is a pointer, it will hold an address. Okay, and here we need to mention the data type. So what is the data type of the object to which it is pointing? It is pointing to another struct node. Therefore, the data type here will be struct node. Okay, and this is the reason why it is known as a self-referential. It is not a class but a structure. This is a self-referential structure because it is referring to itself. It is actually a struct node and it is referring to another struct node. Okay, so this is pointing to another object of the same type as itself. That is why it is known as a self-referential class. Okay, and let us now move to code blocks to implement this thing. Okay, so here first of all let us create the struct node. It contains a data part, int data, and it contains a struct node star pointer. Okay, and let us close it. This is the basic structure of a node, and here let us create a class linked list. In this class, let us have a member struct node n. Okay, and in the public section, let us create a constructor. Okay, so here we are creating a constructor, and this constructor will initialize this linked list. Okay. So let us initialize n equal to null. Okay, so this node is null. So actually do not use n here. Let us use special variable start. Okay, so this is a special variable start, and moreover this is not a simple struct node variable, this is a pointer variable. Okay, so this pointer variable, the purpose of this variable is to, it is a pointer to the first node. Okay, first node in the linked list. So it is a pointer to the first node in the linked list, means it will contain the address of the first node. Okay, so going back here, what we are doing is we are creating a pointer star start. Okay, and this pointer will contain the address of the first node. Okay, because this node's data type is struct node, therefore this pointer's data type is also struct node. Okay, and because initially there are no nodes in this linked list, the linked list is empty, therefore we are initializing it to null. Okay, let's go back here. Here this is the start pointer to the first node, and here we initialize start equal to null because there are no nodes. Okay, then let us create a function void add node, and here we will pass the value which we will use as data in the node. Okay, so here what we'll do, we will create a new node. Okay, so how to create a new node? The new node can be created using the new operator. The new operator will allocate memory to the new node. So how much memory do we need? We need to create a reserve a memory equal to this node. Okay, so therefore we will write new struct node, or we can simply write new node. Okay, we do not need to write struct keyword, we can skip this keyword also. Okay, so we can remove this also, this is also fine. Okay, so new node will be created, and the data type is node. Okay, so it will return a pointer to the node, therefore the data type should be node. uh, let me rephrase this statement. So what it is saying, that it is reserving memory using the new keyword for node. Okay, it means it will create a node in the memory. That node will contain data section and a pointer. Okay, and wherever the memory is allocated, the base address of that memory will be returned. Because this new operator is returning an address, we need a pointer here to store that address. Okay, so n is the pointer which will store the address, and the pointer's data type will be node because it is returning the address of a node. Okay, so now we have reserved the memory. Next, what we need to do? Next, we need to put the values inside the data and the pointer fields. Okay, so n arrow operator data is equal to value, the value which we are passing from here, and n ptr, because this is the first node, so let us make ptr equal to null. Okay, and also we need to change the start. Now we have created a node, so start is no longer null. Instead, start should contain the address of the new node. Where is the address of new node? The address of new node is there in n. So I write start equal to n. So let me explain these things again. So what we are doing is we are writing new node. It will reserve memory for node. This node will be created and it will have some base address. This base address will be returned. So this is the pointer n which will hold this base address. This base address. Okay. And because it is holding the address of a node, the data type of this pointer is n. Okay. So this is the scenario after the first statement. In the next statement, we are putting the data inside this node. Okay, so data will be there, and in the third statement we are writing n arrow operator ptr is equal to null. So here null will be there, and then what we are doing, we are making start equal to n. So initially this is the start pointer, it was null. We initialized it to null in the constructor, but now we are making start equal to n. So now instead of null, it will contain the value which is there in n. So what is the value in n? Value in n is 1000. So it will also contain value 1000. Okay, so it means it is pointing to this node. Okay, so our linked list has been created. Start is pointing to the first node in that linked list, and because this linked list contains only this node, so the pointer of this node, the next pointer of this node is null. Okay, so this is how we can create a node. Okay, so again if you call add node, okay, so you create another node, so what will happen? Another space in memory will be reserved. Okay, and another variable n will be created which will hold the base address of that memory, and then you will put some value here and you will put null here. Okay, and then what will you do? You again do start equal to n. Now instead of 1000, start will contain 2000 because now n is equal to 2000. Okay, so start will point to this node. Okay, and I think there is some problem here. Start is pointing to this node and this node is equal, this node should point to this node. Okay, so it means what we are doing is we are creating a new node, and new node is always inserted at the beginning. Okay, so here instead of making n equal to null, let us make n equal to start. N equal to start. Okay, let me change the code in this here, n equal to start. So let us again see what we are doing here. So when you are creating a node for the first time, this first statement will be executed, memory will be reserved, and the base address of the memory will be there in n. Then you are putting the data in the next statement, so 10 will be stored. Then you are making n equal to start. And because this is the first node you are creating, so start at the beginning is null. So null will be copied here. Okay, and then you are making start equal to n. So start equal to n means start will become equal to 1000. Start will point to this node. Okay, in this way linked list will be created. And then again you call add node. You want to add another node, second node. Okay, so again memory will be reserved and the base address of the memory will be stored in a pointer variable n. So n is actually pointing to this node, and then you are putting the data, then you are putting n pointer equal to start. So now start is not null. Second time the start is not null, but the start is having a value. What is that value? That value is 1000. So here 1000 will be stored. It means this node is pointing to this node. And then we are making start equal to n. So now what is n? N is 2000. So start now instead of 1000 becomes 2000. So start is pointing to this node. So from the start we will go to this node, and from this node we are going to this node. Okay, so let us take another node to make things more clear. Let us suppose that we again call this add function. So again memory will be reserved, the base address of this memory will be stored in a variable n. So n is pointing to this node. Then we will put some data here, and then we will make n pointer equal to start. So start is now containing 2000. So 2000 will be put there. It means this node is pointing to this node. And then start equal to n. So instead of 2000, n is now 3000. So start is equal to 3000. So start is not pointing to this node now. Start is pointing to this node. So every time we are inserting a new node, we are putting it at the beginning. Okay. So in this way, from the beginning, we will go to this first node. From this first node, we will go to this node. From this node, we will go to this node. Okay. So this is how this add node is working. Now let us create another function, void display. Okay, so it will display the contents of the linked list. Remember that start pointer is very important pointer because it points to the beginning of the linked list. If you lose this pointer, you can never access the linked list. Okay, so it is very important to keep track of the start node. And when you want to display this linked list, again we will make use of this start pointer. Okay, so let us create another pointer, node star p is equal to start. Okay, whatever is there in the start is also in p. Okay, and here we need a while loop. While p is not equal to null, cout p data endl and p is equal to p ptr. Okay, so let us see how this is working using the same example. So here what we are doing, we are creating a pointer whose data type is node. It means it will contain the address of a node and its name is p. Okay, and we are writing node star p is equal to start. So start is containing value 3000, address 3000. So p will also contain the address 3000. Then there is a while loop and the condition is p is not equal to null. Is p null? No, p is not equal to null. So the while condition is true. Okay, and we will enter into this loop. So these two statements will be executed. First is cout p data. So p is pointing to address 3000. This is the address 3000. What is the data at 3000? 30. So 30 will be printed. And then p is equal to pptr. So the contents of p will be updated. Okay. So what is pptr? This is 2000. So p will now become 2000. Okay. Again, this loop will be executed while p is not equal to null. P is 2000. P is not null. Okay. While condition is true. So now again p data. P data. Now p is containing value 2000. So the p data is 20. 20 will be printed and then p is equal to pptr. What is pptr? 1000. So instead of 2000, p will now become 1000. Okay. So this is the second iteration of the loop. Again, while condition will be tested. P is not equal to null. P is 1000. P is not equal to null. Condition is true. Then p data. P is now pointing to this node and p data is 10. It will be printed and then p is equal to pptr. Now what is pptr? Pptr is null. So instead of 1000, now it becomes null. Okay, so this is the third iteration of the loop, and after that again this while condition will be tested. P is not equal to null, but p is null here. So the condition becomes false and the while loop will terminate. Okay, so in this way we will display the contents of all the nodes of this linked list, that is 30, 20 and 10. Okay, and one thing to note here is that in order to traverse the linked list, we used a pointer p where we copied the contents of start. We did not change start. Okay, so if instead of p we simply used start, then what would happen? The value of start ultimately would become null and we will lose the access to the linked list. Therefore, it is very important to preserve the value which is there in start. Whenever you want to traverse the linked list, you want to move into the linked list from one node to another, always copy the value of start in another variable. Do not change the contents of start. If you change the contents of the start, then you will lose the access to your linked list. Okay. So this is our linked list and I think it is complete, and then here I put semicolon and here int main. Let us create some nodes in this linked list. So linked list L1, let us put value 10. So it is not, I think we need to call the constructor here. Okay, constructor will be called automatically. So start, what will happen when we write linked list L1, this constructor, default constructor will be called and the start pointer will be initialized to null. Okay, then we will create other nodes. L1 dot add node 10. $20, $30. So we add 3 nodes and then L1 dot display. Okay, and then return 0. Okay, let us run it. So this is running Perfect. This is how we can create a self-referential class. And in this example, this self-referential class is a linked list. This is called self-referential because it is pointing to itself. Okay.